My screen is visible.
Yes, ma'am.
Okay.
Yes, ma'am.
Thank you, students. So, good evening, everyone. I'm Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL and whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ISER Pune. So students, with this we have reached to end of this course, and in today's class we are going to revise every concept which has been covered from week 1 to week 8. So if you recall, in first week we have covered basics of NMR, nuclear magnetic resonance, plus we have covered electrophilic aromatic substitution. So I hope now my screen is visible to everyone, right? Students, yes or no?
Yes,
Okay, okay, thank
yes,
you.
Yes,
ma'am.
ma'am. Ma'am, screen is visible,
Yes,
but
ma'am.
voice is breaking.
My voice is breaking.
Yes, ma'am.
Yes, ma'am.
Okay, let me use my earphones.
Ma'am, you are not audible.
Actually, I'm not speaking. Just give me 1 minute. Let me connect my headphones.
Okay, ma'am.
I'm going to give a last try on this. Then we will start in same way. Students, now my voice, is it audible or clear to everyone, or still it is not clear? Students, is now my voice audible to everyone?
Ma'am, you're not
Ma'am, you are not audible.
Not
Ma'am,
audible.
you are not audible.
Okay, okay, okay.
Ma'am,
I,
only screen is visible.
I don't know what is happening today. Fine.
Yes, ma'am. Audible.
And my screen is also visible, right?
Yes, ma'am.
Yes, ma'am.
Okay.
Visible.
Okay.
Yes, ma'am.
I hope no problem come now. Okay. So students, in week 1 we have covered electrophilic aromatic substitution, in which electrophile is going to replace your hydrogen. Okay. We know benzene ring have 3 pi electrons, or we can say, sorry, one pi bond contains two electrons, so it contains electron cloud. So obviously it is going to invite external electrophile to attack onto it. Whenever external electrophile will attack this, a positive charge will develop on ring that can undergo resonance, and it can do resonance in these three forms. And at last, what can happen, this carbocation can undergo elimination. How? External base will abstract this proton, and this positive negative will form bond. Aromaticity will be back. In total, what has happened is electrophile has replaced your hydrogen. Is it clear? Electrophilic aromatic substitution?
Yes, ma'am.
Okay. And now my voice is also clear, right?
Clear, ma'am.
Okay.
Yes, ma'am.
Thank you. So, students, there can be two types of groups on benzene ring: deactivating groups and activating groups. In general, deactivating groups are your meta directing, and activating groups are ortho para. And if you want to recall how this phenomena is happening, let's say you are having here deactivating group. Now electrophile can attack onto two position, one at ortho and one at meta. Let's say you are doing attack of electrophile onto second position. So in these three resonance, this carbocation will be nearer to your electron withdrawing group. So this is not a stable resonating structure. But if you do meta attack, student, here positive will come and negative will be attacked by your electrophile. Okay. So what you can see here is this positive charge is away from this CF3 group in all three resonating structures. You draw, if you will draw, you will be clear in this. Okay. So from take home message from this slide is, whenever you are having deactivating group onto your benzene ring, it will give you meta product. Okay. But let's say if you are having activating group by means that any group which is going to increase electron density of your benzene ring. Okay, that is your activating group. So in case of activating group, if you are doing ortho and para attack, this positive charge is near to your lone pair containing atom, which can be stabilized by its mesomeric effect, right? So therefore, in case of activating group, these ortho and para are working, and in case of your deactivating group, meta attack will be favored. Till this slide, everything is clear. Do you have any doubt?
Clear,
Ma'am.
ma'am.
This is summary
Ma'am,
of
one more
your
Clear.
thing, that when
week
the
1.
CF3 is attached to the benzene, so what happens is meta is favored than ortho, because in the case of ortho, like there'll be carbocation formation in the carbon having CF3, so that will actually make it unstable,
Exactly.
right? Okay, ma'am.
Good. So this is overall summary of electrophilic aromatic substitution. If there are two groups on benzene ring, one is your electron donating and one is your electron withdrawing, you should listen to which group? Electron donating group. Why? Because electrophile, which is incoming electrophile, obviously it wants to go to the place where electron donating group will direct it. Okay. After that, what we have covered is nucleophile aromatic substitution. But before few slides, I have only told you that benzene ring is electron rich. So what can be done on benzene ring so that a nucleophile can substitute it? You should anyhow decrease the electron density of benzene ring. Yes or no? Okay.
Yes, ma'am.
So nucleophilic aromatic substitution can take place in two ways. First is your addition, then elimination. When addition can appear, when addition can be done on this benzene ring, when already, you can write in your notebook, when already there is presence of electron withdrawing group on your benzene ring. Okay. So let's say here nucleophile is your OH negative. First it will do addition. Addition means only, for example, HBr addition on alkyne. That is simple your addition. Here, if OH negative adds on to here, negative charge will go there, and you can see that while drawing resonating structure, this negative charge is coming just next to nitro. NO2 is electron withdrawing group, it can stabilize that carbon ion, right? At last, what will happen? This negative charge will go back and remove your F minus, and aromaticity will be back. What has happened here is a nucleophile, that is OH negative, has substituted your fluorine, that was itself a nucleophile. So this is nucleophile aromatic substitution. It can happen in two possible ways. One is your addition, then elimination. When it will appear? When there are already electron withdrawing groups present on your benzene ring. Other than this leaving group. Okay. See here nitro was already present. Therefore you can easily do addition. But what in case if only halogen atom is there? First thing is first thing is you need a strong base. Why you need here a strong base? Because you are abstracting benzene protons, right? So base will abstract this proton, this negative charge will go back and will remove this halogen. Generally here halogen is there, and you will get unstable intermediate, that is benzene. Why it is unstable? Ideally this sp carbon should have a bond angle of, that cc bond angle, 180-degree, right? Not cc actually, these groups should be at 180-degree to each other, but here they are at 60-degree, right? Now after formation of benzene, when nucleophile is there, what it can do is positive can come here, can come here also, but since this is symmetrical we can do both ways. So positive NH2 will attack onto your benzene, and this negative charge left will abstract proton from your water, and will, and here your nucleophile has substituted that halogen atom. So this is your benzene mechanism. I hope you can easily distinguish between when to operate what mechanism. In this slide, has anyone is anyone not clear?
Yes, Miss.
Clear,
I
na?
can't clear.
You can
No.
solve any question based on this, whatever will come in your exam. Only, okay, let me tell you which type of question can come from this slide. First, they can ask you whether it will go through addition then elimination or elimination then addition. When you are going to do first addition, when already there is presence of, when already
Electron withdrawing group.
already there is presence of electron withdrawing group on benzene ring. Some can ask you which will have more rate of nucleophilic aromatic substitution among this and among, for example, you have this substrate fluorine. For more clearer details you can go to my previous slides. Okay, in that I have explained in brief, in detail,
Okay.
sorry.
Okay.
Here if two nitro groups are there among A and B, which will have more reactivity towards nucleophilic aromatic substitution? A or B?
B.
B. More the
B.
number of electron withdrawing groups present on your benzene ring, more is the rate for nucleophilic aromatic substitution. Clear? And I hope benzene mechanism so you can do. I'm again suggesting everyone, please go through my videos earlier I have uploaded on to my YouTube channel. Okay, go through them. I'm just going here in brief because we have to cover all the topics. At last, you can ask me any doubt from any topic. Okay. After that, what we have covered is till now, what we have covered: electrophilic aromatic substitution, nucleophilic aromatic substitution. Now we are going to cover nucleophilic additions. So I have told you here three models, right? Can anyone name them? First one,
Felkin
Falcon.
model,
Then
translation model, and
Transport.
Cornforth
Cramscalation
model.
model, and one another name, Cornforth model, right? Okay, before going ahead, just tell me, have you studied all or gone through all the slides so that I can ask you in between? Because today is revision class. I have already taught you whatever I need to teach you in this course. Has everyone gone through all the slides?
Yes,
Because
ma'am.
I am going to take test in last. Whenever we are done with this theory part, I will ask you questions. Okay, so get ready for that. So students, listen to me carefully. When to apply Falcon and model? Whenever alpha carbon or carbon next to your carbonyl group having large medium small group, but alkyl groups most preferably, then you have to apply this model. In Falcon and model, what you have to do, you have to draw that large group perpendicular to your carbonyl, small here, medium here. Why small here? So that nucleophile can attack from smaller group side, right? Then it is clear. In starting, this carbonyl was like this. After attack, if it is attacking from left side, it will form V in right? This nucleophile has attacked, OH become like this part. And remaining things are same.
Ma'am, can you
MEHPH.
please repeat?
Okay.
Yeah, ma'am, can you please repeat?
Okay. See, uh, according to this model, can you keep these things like this? That in straight carbonyl. Okay, are you clear with Newman projection? You are comfortable with Newman projections, right?
Yes,
So,
ma'am.
so horse
Yes, ma'am.
Newman. Okay. According to Falcon and model student, listen to me carefully. Put large group perpendicular. Okay. Now another two left positions are here. Small among methyl and hydrogen, which is small? Hydrogen size wise. Okay.
Hydrogen.
Hydrogen. Okay, wherever you are having maximum doubt, now stop me on that slide. I can explain you again. Okay. So nucleophile is going to attack from smaller side. Now what will happen, student? If this nucleophile is going to attack this carbonyl here, right? It will become like this V OH H. When it attacks, it will go like this, na? It can take proton from your reaction medium, and here nucleophile is there. Clear? And this circle was already there where methyl H and pH was there. Is this clear? Clear to everyone?
Yes, ma'am.
Okay.
Ma'am,
Here,
one thing is like when nucleophile attacks, right, it will attack through hydrogen atom, right? Because that is actually small atom. But in the case of methyl atom, if it attacks, then there will be a steric hindrance.
that
So that's the
transition
reason why
state is also
nucleophile attacks
possible.
on
See,
methyl and hydrogen.
but here steric hindrance is there. This symbol is for steric hindrance.
Yes,
Okay.
ma'am. Yeah.
So more stable transition state is this. They can also ask you what is this trajectory. I have already told you name of this trajectory. Okay.
Okay, ma'am.
That 107 degree, that nucleophile attacks your carbonyl at 107 degree. Okay. I hope till this point everything is clear, right? Okay. Here, students, here your nucleophile is methyl only. So now main thing, how to draw from this conformation to this wedge dash. Okay. See here nucleophile and pH are at 180 degree to each other, right or not? Okay.
Yes, ma'am.
So if you draw that form, na wedge dash or zigzag, I will these bond, this one and this one are at 180 degree to each other. Okay, let's say give one to pH and this is your nucleophile is CH3 only. Clear? Now students, how to see on carbon where, okay, one thing is not clear here. This methyl, this is your nucleophile and this is your methyl which was already there in molecule. So don't get confused from here, right? In your final product, student, your nucleophile and pH are opposite. They are opposite. Now what to do? On carbon, where nucleophile is attached, what two other atoms are left? I'm asking to you, students. On carbon, where
OH
nucleophile,
and H.
huh. So on carbon, where nucleophile is there. So this is your nucleophile only. Now other things remaining are OH and H. So just simply write. Don't make stereo. Just simply write. On carbon, where pH is attached, other two atoms left are Me and H.
Methyl and
H and
Huh.
CS3.
So just make Me and H. Now last thing remaining in this, what? Stereo. If whatever groups are which you are taking as a reference that are 180 degree to each other, put them in a box. Now see this methyl and OH, they are at they are at same side or different side with respect to this
different
square,
sides.
with respect to this rectangle, I say they are same side,
Same side.
right? This H
Yes,
and
ma'am.
OH are at different,
Same.
or Me and H are at different, but this Me and OH are on same side. So yes, they are on same side. Now you can draw in this way also, on wedge also, but relative stereochemistry should be seen only. Now tell me, is it clear to everyone how I am drawing to that Newman projection to this zigzag wedge dash projection? If still not
Ma'am,
clear, I can repeat. Huh? Ask.
ma'am, till yes, ma'am. Ma'am, till here that Me and OH will be seen, that is clear. But
Huh?
while representing them, instead of this dash, we could have also drawn
Wedge.
the solid wedge.
This is also correct.
I'm asked.
Relatives,
Okay.
actually, questioner wants to ask you relative stereochemistry of those groups. Here we are not doing enantio selectively. Here we
Okay,
are
ma'am.
talking about diastereoselective. This Falcon and model gives you diastereoselectivity, right? It is relative.
Yes, ma'am.
You can form, but you should know that OH and methyl will be on same side or different side.
Yes, ma'am.
More doubt on this slide. Today I'm not in hurry. You can ask me anything. I will clear
Ma'am,
you.
in some of the
Ask in some of the.
ma'am, in some of the questions I have seen that both options are given. Both are in same side. Even dashed one is given and in solid one is also given. I'm not having that
Then
question, remembering
in
that.
that category, what is happening now? Let me tell you. For example, here student. Here already they have given that this methyl is in dash, right? And from next slide we know that sin is the major one. Okay. If methyl and OH are on same side, so you have to draw that stereochemistry with respect to this. What they want to conclude is you don't have to change stereo of this center which is already given in your question. Correct? In question
Yes, ma'am.
already your methyl is dash. So i- in directly what is conclusion from this slide, you have to draw OH also in wedge, dash also. Why? From model what do you know that methyl and OH should be on same side, correct? Methyl stereo we already know, methyl is at dash, so incoming OH will also be at dash. Now clear?
Yes, ma'am, clear.
Good.
Ma'am,
Huh.
ma'am, so whenever we use Falcon and model, then always sin is a major product.
Actually, not always. Why? Let's say here nucleophile was not CH3. Let's say it was OH. Okay, OH it was. So if in place of CH3 OH is there, always in zigzag, chemists or scientists prefer that this planar bond should be occupied by alkyl groups. Here nucleophile was your alkyl group, so they have taken alkyl groups at trans to each other. But let's say here nucleophile is your OH. Okay, so they, and not OH, let's say SPH. Okay, so they will okay, that problem I will discuss you in next slide. There we will cover. I understand your doubt. Okay, just give me time. Okay, when you have to apply Cram's scalation model, when at alpha carbon among three groups, one of the group is your heteroatom. This is your Cram's scalation model. Okay, when you have to uh, apply this model when there is heteroatom. Actually, it is not Cram's chelation model, it is Conforth model. Chelation model comes into picture when your this cation is bivalent. If you remember my last class, Conforth model. So, student, according to this model, till alkyl group you have to follow Falkinen model. No doubt from that. After that, if heteroatom is there at that chiral center, what you have to draw? Draw in similar fashion. Just replace that large group by heteroatom. Other things will be same. Put your medium group here, small group here. Everything is same from this point. Is there any doubt on this slide? Students. So one student was asking me, ma'am, will it, according to Falcon and model, will it always be sin? So student, let's see in this example. In this example, this is the final model which is giving you answer. But while writing in your this zigzag model, these two butyl groups, if you take this bond as a reference, let me mark it. If you take this bond as a reference, these two groups are at planar side, yes or no? Okay, let me first explain you what is planar. This is a this is a tetrahedral this molecule is having tetrahedral geometry, right? So student, two bonds are in plane. Two bonds are in this plane of the screen. Methyl is coming towards you, hydrogen is going away from you. Is it clear? So
Yes, ma'am.
as per convention in zigzag model, these two planar side should always be occupied by any alkyl group. Okay. So now in order to bring this alkyl group here, trans to butyl, they will do 120-degree rotation, right? On 120-degree rotation, NMe2 will come here, hydrogen will go there, and this alkyl group and this alkyl group will come here, and finally you will get this. Now butyl and alkyl group, they are trans. Good. On carbon attached to butyl, other two atoms are OH and H. Okay, OH and H is at dash. On backside carbon, that is on big circle, right? Apart from your this group, this is propyl actually. What other two atoms are there? NMe2 and H. So NMe2 and H. Okay. If we put this in rectangle, H and OH are on same side. So H and OH are on same side. Now you understood why I can't not always say sin? Because sometime we have to do rotation. Why? So that alkyl groups can occupy those planar side. Heteroatom should not occupy that planar side. Heteroatom should be either on wedge or dash. On that planar side, preferably alkyl group should be there. If it is not there, you have to do rotation, because in conformations rotation is allowed. Yes or no?
Ma'am,
Huh.
after rotating, how did we know? Because in the question, NME2 is in solid wedge, and how did we know that it will be in dash in our final product?
Okay. Here, if you see here, if you draw in similar fashion as they have drawn in question, this is your NME2, right? From this model, butyl and this propyl group are trans to each other, right? So this is your, let's say here OH is there. This is your butyl, this is your propyl, right? Okay, okay. One thing I have done wrong. Wait. Okay. Here it will come OH and here butyl. Now, one thing is clear that if you take this bond as a reference, this propyl and butyl are trans. Okay, butyl and propyl are trans. NME2 and OH are opposite to each other. Yes or no? So we know the
Yes, ma'am.
stereochemistry of NME2
Yes,
is
ma'am.
it is at wedge. So OH will be at dash. Clear? So one way questioner can give
Yes,
you
ma'am.
option this and this. Student, when you will do RS nomenclature, you will find that both the stereo are same. Let's say I have not calculated. Let's say this is R, this is S. When you will see here, na, this will be R, this will be S. It is only a way. This is a different way of representation, but stereo is same. Actually, they have done this molecule actually swapped. Are you understanding?
Yes, ma'am.
One thing you should always remember that you wait, you can't change stereo of this chiral center which was already there in your starting material. You can only decide stereochemistry of this carbonyl center. Clear? You can't change stereo of this.
Yes, ma'am.
See, this molecule is like this. They have drawn in this form. Stereo is same. Correct? Just
Ex-
do RS nomenclature, you will find it. Okay, that both the
Yes,
molecules are same.
Excuse me, ma'am.
Ask.
Ma'am, facing a problem uh, related to your annotation. What you are writing that reaches to us somehow late, ma'am. It will help you full if you resolve it, ma'am.
Okay, miss, you are saying that my laptop is still hanging. My voice is also
Yes,
not
ma'am.
Yes,
clear.
ma'am.
No, my voice is
Your
clear,
voice is
but
clear, but laptop is not work well.
Actually, if I will do na, it will end the class now. Okay, let me give one try.
Yes, ma'am.
Can you follow my this laser pointer? Everyone, am I audible, right?
Yes,
Yes,
ma'am.
ma'am, you are audible.
And can you follow my pointer? My pointer is
Yes.
visible, right?
Yeah, yeah, I can follow it, ma'am.
Okay. No,
No, ma'am.
pointer is here
No,
on
ma'am.
written part, red color.
Yes, ma'am. Can
Clear,
see.
na?
Yeah, I
I
can follow
I
it.
think it is visible. Just
Ma'am,
be
it's visible,
just
but is
bear
Yes.
me.
actually
Yes, ma'am.
hanging.
Okay. Actually, I don't know. In this class only it is
Ma'am, there
happening.
is much.
No, ma'am. Actually, I have a doubt.
Just give me 1 minute. Let me resolve this problem. Yeah. Ask your doubt. Ask your doubt, student. Is my screen not visible? Students,
Yes, ma'am.
wait.
Yes,
Yeah,
ma'am.
yes, ma'am. Tell me.
My screen is visible, right?
Yeah, it's visible, ma'am.
Okay. Ask.
Yes, ma'am.
Someone was asking me something. Ask.
Yes, ma'am. Actually, it's me. I actually had a doubt. Like, whenever based on the stereochemistry, like the OH and NME2, like one is the wedge, one is a dash. So the
Huh.
thing is, like, both has to be on the opposite side. Am I right? Like in the case of Newman conformation.
Okay. My pointer is visible.
Yeah, it's
Yes.
visible.
Okay.
Yes, ma'am.
See, as per this model, you have reached to conclusion that when your butyl and propyl group are trans to each other, this NME2 and OH will be opposite, right? This NME2 was already given in your starting material at wedge. So in product, you have to draw that OH as on dash. Why? Because when butyl and this propyl are trans, they are also trans, and they are trans, so they will be trans. Now clear?
Yes, ma'am.
First you have to draw model, then you have to see exact stereo of the already present chiral center in it, and then you have to draw. Can we move ahead, students? We
Yes,
have
ma'am. We can
lot to
move ahead.
cover.
Yes, ma'am.
Just bear me for half an hour only, then we will do question answer. In that, I hope no problem will come. Okay, this is your C plaque model. Can anyone make me understand what is actually C plaque model, if you have studied anywhere? This is your C plaque model. Whatever I'm writing on screen, is it visible to everyone?
Yeah, it's
Yes,
visible,
ma'am.
ma'am. It's
Thank
Yes,
visible.
ma'am.
God.
It is.
See, nucleophile is there. It can attack from two sides, axial as well as equatorial. Okay. Let's say if nucleophile is coming from this side, it will attack from here. Okay. And if it attacks from equatorial side, it will attack from this side. See, student, this concept came from molecular orbital analysis theory. So this is imaginary concept, but you have to imagine. Let's say, students, if this nucleophile is coming from axial side, its sigma star will be here. Okay, let me clear this thing. See, student, if sigma bond is like this, if sigma bond is this, its sigma star will be exactly opposite to it. Okay, sigma star. You remember, no? 1s. One was sigma, one was
91 and
sigma
1
star. Okay. So what is their hypothesis is that whenever this carbon nucleophile bond is going to form, this will be sigma star, and this forming sigma star can be stabilized by this CH bond, right? In case of axial attack. Is this thing clear? That C nucleophile sigma star can be stabilized by CH sigma bond. Clear? But when it is doing equatorial attack, its sigma star will be here, and now which bond can assist it? This CC. Now students tell me, among CH and CC, which have better sigma donation? Among CH sigma bond and
CH.
CC sigma bond, which can donate better its sigma bond?
CH
CH.
sigma bond
CH
better than it.
students. CH students. Therefore,
CH.
therefore in general axial attack is favored. But what happen is, student, one another factor come into picture when size of nucleophile increases. As size of nucleophile increases, you very well know that there are 1,3 diaxial interactions present on your cyclohexane ring. So whenever your nucleophile is getting bigger in size, like methyl lithium, ethyl grignard, propyl grignard, what happened is equatorial attack becomes major. Why? Because due to increase in size, that 1,3 diaxial interaction will increase. So you should follow this table, that whenever till small nucleophile you have to do axial attack. Whenever your nucleophile size will increase, you have to do equatorial attack. You can go by these figures. Okay, till methyl everything is good, but after that, okay, understood whatever is there on this slide? If understood, just tell me this answer. Let's say this is your
Ma'am,
pH.
one more thing. I have a doubt.
First answer this question, okay, student.
Okay.
Let's say we are having ethyl grignard. Now tell me whether it will do axial attack or equatorial attack. This is very good question.
Equatorial.
Equatorial.
Equatorial. This is oxygen, right? Oxygen.
Axial.
Clear.
Clear. Tell me, axial or equatorial?
Axial attack, ma'am.
Axial attack.
Whoever is saying axial, can anyone, one among them, can tell me why axial? Because now there is no 1,3 diaxial interaction which can hamper. So in this, because CH2 is replaced by oxygen atom, and lone pair can't create your steric hindrance, right? They can't involve in 1,3 diaxial interaction. So now in this case, whether nucleophile is big, you have to do axial attack. Another reason for that, another reason is that, student, if electrophile attack is there, sorry, equatorial attack is there. This will be sigma star, and now this sigma star will be stabilized by CO. But you know, CO is worse. CO is worse than your CC. Okay, because whenever oxygen is there, how can it let carbon to donate its sigma electron to other, right? It I hope you got this point. Among this oxygen carbon bond, oxygen will not allow this carbon to donate its sigma bond to sigma star. Okay, and you are
Ma'am, because like the
Yes,
carbon is
ma'am.
electron deficient, right? In the
e-
CO bond, carbon becomes electron deficient, so therefore it can
exactly,
donate
exactly.
electrons.
See, sigma star is actually vacant. So how will you stabilize that vacant orbital? By electron density. But CO sigma is itself electron deficient. It can't stabilize that sigma star. Clear? So this is your C plaque model.
Yes.
I hope you are clear. I think
Ma'am, one
in
more
I
doubt I
think in
have.
this whole course, this one was quite tricky topic. What? Your Felkin model, your Kram-Skillation model, your Conforth model, and your C-Plaque model. Felkin model, when you have to apply, when on alpha chiral center there are alkyl groups present. You have to put large group here, do attack from small side. This is your Felkin model. In your Conforth model, you have to put heteroatom perpendicular to your CO. And in your Kram-Skillation model, student, you have to put heteroatom small heteroatom near to your carbonyl, so that that bivalent cation that is given can coordinate. Okay, this is your Kram-Skillation model. So you have to clearly read what is given on arrow. On arrow, if it is a monovalent atom like lithium, sodium, go by simple Conforth model and your Felkin model. But if on arrow it is written zinc or magnesium bromide, you have to go by Kram-Skillation model. Now you can ask me doubt in this topic. Start.
Ma'am, I have a doubt.
Hmm.
Ma'am, that is like you mentioned that depending upon bulkiness, so the attack happens based on the axial and equatorial interaction. So what I want to say is like higher the bulkier means like more the equatorial position will be favored than axial because there will be static hindrance.
Exactly. Exactly.
Okay.
Another doubt. If clear, can I move ahead?
Yes, ma'am.
Yes, ma'am.
Okay, till this point, everything is, I think, clear. Electrophilic aromatic, nucleophilic aromatic. If still not clear, I will suggest you please go through my earlier videos, right? It will be really helpful for your exam. Exam is on Saturday.
Yes, ma'am.
Okay.
Yes, ma'am.
All the best, everyone.
Thank you, ma'am.
Thank
Uh,
you.
okay.
Thank you, ma'am.
Excuse
Will
me, ma'am.
ask.
Ma'am, do you know that what will be the weightage of like marks?
No,
Will
no,
it be
no.
equal across all the
I
weeks?
don't
Like,
know anything about exam pattern. My work is only to teach you, nothing, because all these things are handled by external PMRF agency. We are not part of that. We just have to take tutorials, nothing else.
okay, ma'am.
Okay, should I give more time to this slide, because this we have covered in last 3 or 4 lecture, right? Kinetic thermodynamic. If you will say I will invest time here, do you have any problem on this slide? How to decide between kinetic versus thermodynamic?
Ma'am, I want to say one thing. Like here in this case, like kinetic is more favored than thermodynamic because of the low activation energy barrier.
Huh.
That is the
And when
reason.
kinetic product will form at low temperatures, minus 78, and bulky base.
Okay, ma'am. Yeah.
And
So it will attack
second,
on the less substituted side.
huh, yes, because this is more what will say I will say more feasible for a base to abstract this proton, as it is least hindered. This is hindered, this proton is hindered to abstract by base.
Yes,
Therefore,
ma'am. Because of that, static hindrance will happen between two methyl groups. If I have
huh,
to extract proton from between two alkyl groups.
exactly.
Okay.
Any other doubt on this slide? Because at
No, ma'am.
last I will take your doubts, okay, where you are facing problem. This so I know you can cover. Okay, aldol reaction. Aldol reaction, anyone is having doubt? Okay, let me revise. In aldol student, your starting material can be aldehyde or ketone. Okay, aldol can be of two types, self aldol or cross aldol. Let's say you are given CH3CHO. So one mole of it will behave as your electrophile, other mole will behave as your nucleophile. Your nucleophile will be enol or enolate based on the condition provided. Okay. So what happen is this is your CH3COH. Okay. Base will abstract proton from this alpha carbon to carbonyl, and this will be enolate and it will attack here. You will get CH3 COH CH2 CHO, and at last water molecule leave and you get this alpha beta unsaturated system. Whenever you are having in product alpha beta unsaturated aldehyde or ketone, it is it is marked that it is aldol reaction. And I have also told you how to trace back its path, right? You can do
Yes,
like,
ma'am.
for example, someone asks you write starting material for formation of this cyclopentane, right? How will you do? Very easy. You can again write the steps. First, form beta hydroxy ketone, because by your memory you know that aldol product is your beta hydroxy. So this is your alpha, this is your beta. How can you trace back its path? C double bond O OH. This is your beta hydroxy. How can it form? Just give OH and this side H and break that bond. HCO CH2 CH2 COH. Have we done miss? Okay. See here, student. This is carbon only. Okay, so we can't write H. This is carbon. Clear na? So this is the starting material. This is example of your intramolecular aldol reaction. Base will abstract proton from this carbon and it will attack here. So how many member ring will form? 1, 2, 3, 4, 5. I hope there is no doubt in aldol reaction. First, beta hydroxyaldehyde or ketone forms. After that, dehydration takes place and result into formation of your what? Alpha beta unsaturated system. Clear? Just say yes or no. Clear? Not clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Clear, ma'am.
Now
Yes.
comes benzylic acid rearrangement. Very easy rearrangement. Today I have also brought some name reactions which I have left in earlier classes. Okay. I realized that these are left, so I brought here. See, whenever you are having diketone in your starting material, on arrow base is there. Okay. What it will do? If you let's say if you don't know nothing, okay, just apply your common sense. O negative OH. Obviously, here there are no protons to abstract, so it will behave as a nucleophile. If it behave as a nucleophile, when O negative will come back, it can't eliminate OH negative, because then you will get your starting material back, right? So only possibility is that this phenyl group transfers to this adjacent carbon, and this is your benzyl OH O negative, pH, pH. And at last, what will happen, student? Instead of this having OH, intramolecular proton transfer reaction will take place and O negative will be there. And this is your final product for your benzyl benzylic acid rearrangement. Clear? Very easy, na? First, nucleophilic attack, then transfer of that alkyl group to adjacent carbonyl, and done. It is similar to which reaction? Which carbonyl reaction? Canizaro?
Yes, ma'am. Cannizzaro reaction.
There we have to transfer hydride. Here we are transferring alkyl group. Clear?
Yeah, right.
Huh. Good. So this is your benzyl benzylic acid rearrangement. Next name reaction, which is your Cannizzaro reaction. Cannizzaro reaction, so you know, base will come, attack onto your. Okay, Cannizzaro, for Cannizzaro reaction, main condition required is
No alpha hydrogen.
exactly. Very good.
Oh, alpha hydrogen.
Huh. So, lack of alpha hydrogen. Mechanism, you are very clear that O negative, OH, H. Another molecule is also there in your reaction medium. O negative will come back, transfer this hydride here. It itself become acid. This reaction is also known as, student. It is also known as
Disproportionation reaction.
disproportionation reaction because one molecule get oxidized and other molecule get reduced.
Reduced.
And one thing also, you should at last this will be in anionic form and this will be in neutral form, right? Because this carbon ion, this oxyanion is stable while this is not. Okay, what I was saying is, you got this product. After that, you have to do that intramolecular proton transfer. This hydrogen will go there and this will become carboxylate. Why I am emphasizing on them? Let's say they have given you some deuterium labeling OH or water, then you can easily distinguish from where this deuterium is coming. Okay, let's say, let me clear your doubt here only. PHCOH. Let's say you are given PHCOH and arrow it is written OD negative. Can you tell me the product? You also draw, I am also drawing with you. PH. Oh, okay. When you are given that deuterium labeled atom, when questioner wants to know whether you know the mechanism or not. Okay. So first it will do your nucleophilic addition, OD, H. And let's say they are labeling this hydrogen also as a H star. So another molecule in your reaction vessel is there. It will be O negative, H star, H star. Clear? Plus what you will get? Tell me, student. PHCOOD.
PHCOOD.
Huh.
Yeah.
And final product will be PHCOD, H star, H star plus PHCO O negative. This will be your final product. They can ask you, student, this also. Not in this NPTEL exam, but in your future exam also. They can do deuterium labeling and can ask you these type of things. So for that, you should know clearly the mechanism for this reaction. Clear? If not, stop me here and ask. Can we move ahead, students? Dipali,
Yes, ma'am.
Bhumika,
Yes, ma'am.
Yes, ma'am.
and boys.
Ma'am, one more doubt. In
Okay,
the second
ask,
step, what
ask.
happens when the OD attacks the nucleophile?
Huh?
When the OD attacks the nucleophile, so what happens is
OD
when
attacks your carbonyl, right?
yes, ma'am, the carbonyl, yeah.
Huh?
So what happens when the luminous comes back as carbonyl and then removes hydrogen, and that hydride will attack on the another carbonyl such that it forms PHCH2O negative,
Huh?
PHCH2OD. Okay, ma'am.
You are explaining better than me, I think.
Okay, kind of.
Okay. Uh, then let's go to Demjanov rearrangement. So, student, there is what I will say small difference between these two rearrangement. When you are having adjacent carbon OH, that will be a Tiffany Demjanov rearrangement, and when you don't have this OH at adjacent carbon, it will be simple Demjanov rearrangement. Okay, product is different in both the cases. In first case, you will get ketone. Why? Because carbocation is adjacent to your OH. If you remember the mechanism, right? Student, all
Yes,
gone.
ma'am.
You remember na mechanism. This will become N2Cl, good leaving group.
Yes, ma'am.
Positive charge will come here. Then ring expansion take place. I hope everything is clear.
Yes, ma'am. Clear.
Okay, let's move ahead. Julia olefination. Can you read it by yourself, or should I emphasize on this? This is very heavy slide. Let's discuss it later. Okay, this thing I want to emphasize, student. Prevost and Woodward dihydroxylation. Okay, actually the main difference between them is in Woodward you get syn-diols, but if you want anti-diols from alkenes, you need Prevost reaction. Now let's see the mechanism. First is your Woodward reaction mechanism. If at anywhere I am going very fast, please stop me. You are having alkene. In your reaction arrow, it is written I2 silver salt of carboxylic acid and water. If water is given, it is your Woodward syn dihydroxylation. If water is not given, it is your Prevost dihydroxylation. In presence of water, you will get syn product. In absence of water, you will get trans product. Thing to write in red pen. Okay. In presence of water, you will get syn product. Without water, you will get trans product. Okay. Now let's see its mechanism. So students, this alkene is there, I2 is there. It will form iodonium ring. I2 have I positive, I negative. This is your electron rich double bond, right? So it will trap this I positive. Now this three-member ring will be opened by this nucleophilic attack. If this iodine is from above side, if this cycloiodonium ring is above side, your your nucleophile will attack from below side. Till this point everything is clear.
Yes, ma'am.
Yes, ma'am.
Okay, very good. Now, what will happen, student? This oxygen lone pair will push, it will become O negative, and this O negative will attack onto this carbon and will remove this iodine Ag complex as silver iodide, AgI, and will result into formation of this five-membered ring. Is this clear? But one thing is wrong here. Can anyone tell me? Small mistake. This will be your Okay, not mistake, actually they have formed it OH. Okay, no issue. But what will happen, student? What I was saying, this bond will come here, this will become O negative and it will attack here. Clear? And you will get this type of 5-membered ring. Now what will happen, student? Okay, from here. Now what will happen? Water will attack. Water will attack onto this complex. Let me show you this complex in easy way. I'm not drawing this R1, R2, okay? O, C, double bond O. Actually, it will become O positive and it will be single bond. Clear? If you have to draw this mechanism, you will draw like this. Yes or no? Clear? These groups are as it is. Can we move ahead?
Yes, ma'am.
Now what will happen? This water will attack onto this carbon. Okay, if it attacks onto this carbon, you will get CH3OH and OH positive. And after hydrolysis, this bond will be OH, and on this hydrolysis, this will be OH. So it at last you will get syndiol. So this was the mechanism for Woodward reaction. I'm I'm stopping at this slide for 30 seconds. If you have any doubt, ask me. On any step if you have doubt. Okay, if you have doubt on hydrolysis step also, that also I can explain. Water H2O will attack onto this. This will become O negative. This will come back and eliminate this group, and it will leave as CH3COOH. In similar fashion, this will leave as CH3COOH, and it will become syndiol. Clear on this mechanism? You can write on this slide as important slide. I'm 100% sure one question will come from this slide if I have to make the question. I have not made the question, but I know. Clear everything?
No, ma'am. Please once again repeat it.
From which step it is not clear?
Ma'am,
Okay.
from starting, please.
From starting it is not clear. Okay. Let me give one try or one more try. See, this double bond is there, student. This is electron rich. Okay. I2 is there. In I2, what we are having? I plus, I negative. Okay. This double bond will trap that I positive. I negative will leave. Clear?
Yes, ma'am.
Hmm. After formation of this cycloiodonium 3-membered ring, this nucleophile will attack in SN2 fashion from opposite side. It attacks, let's say it is attacking onto this carbon. This bond will break, clear, to get this intermediate. Now this oxygen lone pair will push, this O negative will attack onto this carbon and will eliminate AgI, resulting into formation of this 5-membered ring which I have made. Till this point everything clear? You draw in
Yes,
your
ma'am.
copy by yourself, then you will get clear, then you will be more clear on this. Okay, H2 is there. H2 is going to attack your this oxocarbenium, or I can say oxonium ion. H2O will attack. When it will attack, it will become CH3OH, CH3OH, and this has become OH. Actually, this oxygen has taken H plus from water source, nothing else. Till this point, everything is clear.
Yes, ma'am.
Now, oxygen lone pair will come back and will this bond will break. So it will become OCOCH3 and OH. Now, just hydrolysis has taken place, nothing else. In hydrolysis, this will become CH3COOH and this is simple OH.
Ma'am, actually the OH attached to carbon having methyl group that actually will polarize such that the CO bond, that is oxygen having positive charge, get
Exactly.
neutralized.
This bond will push here and then it will break this bond.
Okay, ma'am, got it.
Actually, you can't say actually. This bond can also come, na? Yes or no?
Yes, ma'am.
Actually, you are telling on behalf of this product, right? Which is written on right side. But when you are
Yeah.
drawing mechanism, you can push lone pair of this oxygen as well as this oxygen. You will get same intermediate in last. Okay.
Okay, ma'am.
Understood? Can we move ahead?
Yeah, we
Yes,
can.
ma'am.
Good. This is your prevost mechanism, student. It is going in similar way till this 5-member ring formation. Now what happened, student, is there is absence of water in prevost mechanism. No water. Now what it will do? Now what will do? This carboxylate anion that was present in starting, right? It will again do SN2 attack. It will not attack onto your oxonium. It will attack in SN2 fashion here on intermediate 5 and it will lead to formation of this trans product. And after hydrolysis, it will also become trans diode. Clear? Only difference is in this step. If not clear, ask me now only. Instead of attacking onto this oxonium ion, which was happening in case of Woodward, it will do SN2 attack here because this becomes now a good leaving group. And after hydrolysis, this will become OH. OH. Clear? Okay, when I was in my BSc, how I used to do hydrolysis for my understanding. We know that H2O is H plus and OH negative, right? We have to do hydrolysis. This is OC bond, O carbon bond. So obviously we can't give OH to oxygen because two heteroatom nearby are not possible. So I will give H plus here, OH here. So in that way I used to write hydrolyzed product. Clear?
Yes, ma'am.
Now you may ask. Someone was asking. If clear, can I move ahead?
Yes,
Okay.
ma'am.
Dinone phenol rearrangement. Very easy rearrangement. Whenever you are having dinone, di-ene, on. Name is clear. Phenol, final product is your phenol. Please see this, or I will say scan this slide for 30 seconds. Because whatever test you are going to give in next 5 minutes, it covers question based on this topic. So scan it and try to understand the mechanism clearly. H plus is there. This carbonyl oxygen lone pair will trap that hydrogen, will form oxonium. Now, if you draw, okay, let me use pen. I will suggest you write with me the mechanism. You will get more clear understanding of that. You are having, oh, student, is still my laptop hanging too much?
No, ma'am. After that, it is
Okay.
No, ma'am.
Sorry for this inconvenience. Okay. Till this intermediate, everything is clear. Nothing, just oxygen lone pair has abstracted that proton. Now, what will happen? Positive, negative, positive, negative. In order to decrease, or I can say reduce the charge of that oxonium ion. OH, positive, R1, R2. Clear? Now, what will happen? 1 to methyl shift will take place, like in this way. I have written like in this way so that you can understand. Okay. Now, if R1 migrates, it will leave here positive charge, as you can see in this intermediate I am marking, and this R1 will migrate there. Now, positive charge is there, and next carbon hydrogen is there, which will eliminate and will give you this phenol. Mechanism is clear.
Yes, ma'am.
Oxygen lone pair activation by proton source, 1 to methyl shift, product. Key point is, you may ask me, ma'am, what group to migrate? That you have to decide by yourself. You have to migrate that group. Listen me again. You have to migrate that group so that the group which is left here can stabilize that carbocation. Let me write it. Let's say here CH3 is there, pH is there. Okay. Now tell me, among CH3 and pH, which group will you migrate? CH3, right? Because
pH.
that carbocation can be stabilized by that pH. So you will migrate CH3
Okay,
there.
yes, ma'am.
Understood? You have to make that intermediate stable anyhow.
Yes, ma'am.
Clear? Okay, question time has come. So take 30 seconds time, rev- have glance on each slide. Okay. And tell me, we will start question answer session. Okay. Let me clear you rules of the game. Now it's 8:40, right? Till 8:50 we will do these problems. I will give you 1 minute time only. You have to solve it. Write answer in your notebook. After we have done all the question, I will ask you how many marks you got. Okay, you don't tell me, you just see your marks where you are now. Okay? And after that session, I will tell you answer with explanation. Rules are clear.
Yes,
If
ma'am.
someone got full marks, they can tell. Okay. And let's have a competition between girls and boys at least. So start. Shall I start?
Yes, ma'am.
Okay, ma'am.
Okay. So your first question is here. Your time starts now. One thing I can do is girls, boys. I will write points here. Okay. From girls, one person can take initiative and tell me answer here, and same with boys. Answer I will discuss at end. 30 seconds left. I hope you have not done cheating.
I'm done.
Have you seen the answer? Okay. Boys, tell me the answer. You all have seen correct option, I know. Girls.
Ma'am,
Ma'am,
B.
actually, we solved it before and then we saw the answer. We already solved it before that.
Okay, I'm trusting
B.
you. Okay. So correct answer is B. Girls and boys are on same rank. Second, another question in dinone phenol rearrangement. Quickly. Okay.
Ma'am, option C.
Option
Yes,
C.
ma'am, C.
Okay. Boys, students, you will be provided with feedback form, I think, in the end of the course. If you really liked my course, if you really liked, then please fill the form. Except from technical glitches, you can write anything.
Yes, ma'am.
Boys, what happened?
Option C, ma'am.
Same answers are coming. Okay, let's see the correct answer. Good. Correct answer is C only. This is difficult question. Take 3 minutes time for this. Let me solve also with you. Anyone solved or not? Do you need any hint for this?
Yes, ma'am.
Okay, simple hint is it will go through carbene intermediate. Your take home homework for this is you should also know product of this pyrrole and furan, okay, with your CHCl3KOH. Anyone knows final product for these carbene reaction? Pyrrole, oxygen. If not, nothing to worry. We will discuss in the end of the class. You take your time first.
And C.
A. So girls are saying A. Boys,
Ma'am, ma'am,
voice is not clear.
ma'am, C.
C. Okay. Shall I lock it? So the correct answer is C. Boys wins by this
Thanks.
by this question. Final result will be at end. Okay. Take 2 minute time for this question, student. Quickly. If you don't know what is thionyl chloride, basically, student, it transforms your carboxylic acid to carbonyl chloride. Not sorry, acid chloride. It will form COCl. Okay. AlCl3 Friedel-Crafts. Third is your Clemmensen reduction. Now quickly do.
Ma'am, what is the second reaction?
What is Friedel-Crafts reaction? Na? In first step, you will get your A is COCl. Okay, let me help you in this. In your first step, what you will get, student? COCl, right? This will be your Friedel-Crafts acylation. Okay, COCl, AlCl3. Remember, this is phenyl ring. You can write in open form. CH2PH, C6H5.
Ma'am, option D.
Girls, option
Option
D.
D.
Ma'am, option B.
Boys,
D. Ma'am, D. D.
D for dog.
but okay, D for dog. But since girls answered this first, here girls will win. So points are equal. Okay. Okay, but let's see what is the exact answer. I don't know. Answer is D only. Okay. Okay. Take 2 minutes time for this question. First, nitration, reduction, diazotization, Sandmeyer reaction, methyl grignard addition onto that, workup. Quickly. I have told you everything. Please don't see on screen.
Option D.
Request option D. Okay, boys are saying option D. Girls, what is your take?
Ma'am, I think it should be option B.
No, boys representative has already answered.
Ma'am, option B should be there.
B. Okay. The correct answer is option B. So girls are ahead. Okay. Okay, another person, his answer was option B in boys category. I don't know the name. If he was saying B, I will consider it. Okay. Quickly. If someone asks you SNAR, it means nucleophilic aromatic substitution. This we have covered in today's session. Quickly, I will give you 30 seconds for this question. Quickly.
Answer C. Answer C.
Option C.
Yes, ma'am. C.
Yes, Mamsi.
See? Okay, good. Again 30 seconds. Very easy problem. It is question from electrophilic aromatic substitution. Since Br2 is given in presence of iron, it will here active electrophile species will be Br positive. One more thing, student, examiner can ask you active electrophile species also in exams. So you should know everything. In nitration, NO2. In your sulfonation, what is your active electrophile? SO3. You can write it
Yes.
in your notebook. This is SO3, active electrophile. Okay.
Yes.
In your Friedel-Crafts alkylation, that R positive. In your Friedel-Crafts acylation, RCO positive. That is called acyl cation. Okay, forget about that. Tell me product here.
Ma'am, option D.
D.
Boys,
Option D, ma'am.
option
D
D.
only.
One answer I want from boys side. A, B, C, D. What?
Option
Ma'am,
D,
D.
ma'am.
Fourth D.
Now you are correct. We will discuss all the question. Okay, solve this problem. Are you confident now, right, in solving these type of problems? Do you need any hint in this problem? Simple activation of alcohol, leaving as water, leaving behind carbocation, some shift will be there, and you will get the product.
A.
Girls, A. Girls are learning better than boys, huh? Positive. Now some shift. 2 hyperconjugation, 2 here, 2 hyperconjugation. Okay. And so, boys, what is your take on this?
Ma'am, your screen is not visible.
My screen is not visible.
I'm actually visible this thing.
Ma'am, it's visible.
Yes, ma'am. Screen is visible.
Don't give me shock, yaar. Can I disclose the answer?
It should be option A, ma'am.
A.
Yes, ma'am.
Good. Okay, this is also nice problem. Take 2 minutes time. If you need any hint in this question, please tell me.
Yes, ma'am. Actually, like, what is the function of I to Ki?
Okay, I2KI will release I plus. From now, you just take I plus and do whatever you want. Okay, let me give you a hint. This olefin is there. First, cycloiodonium ring will form, that three-membered ring. Then COH will be deprotonated in presence of sodium carbonate. That O negative will attack that cycloiodonium ring. Now, so I think you can do, right? Right? First, formation of iodonium ring onto that olefin, which will be opened by your carboxylic acid oxygen. Student, please take care of the stereochemistry in this question. Let's say you are making cycloiodonium ring from wedge side. That COH will attack from back side. Okay, remember that thing.
Option D.
Option D. Option B or D?
D.
Option B, ma'am.
Ma'am, option B.
Correct answer is
Option
option
A.
number A. Time up, time up. No one has answered, so I will explain, okay? Please remind me. Oh, it was last question. Let's start from here only, okay? Student, you have to see first option, okay? But let's say if we are going with this option, first that iodonium ring will form from alpha phase or dash side. I positive, CO, O. In presence of this Na2CO3, it will become oxyanion. It will attack here, okay? If it is at dash, on SN2 attack, it will be at wedge. SN2 reaction occurs with inversion of configuration, correct? CH2COO, and it will be at dash I. This will be at wedge, correct na students? If this is at
Yes.
wedge, this hydrogen will be at dash. And in general, this junction is cis. So the correct answer is option number
A.
clear.
Yes, ma'am.
Before that, tell me who is the winner, girls or boys? I think girls, right?
Good.
Okay. You are clear now in this question. This question was clear. Actually, I have drawn it here in wrong way. Let's make it again. Okay, as you have solved all these questions today, you will direct me, ma'am, what to do. After this, girls was first, I think. After this, what you have done? If we see current status of this carbocation, it is having two hyperconjugation plus one resonance. Can we make it more stable by any means? Huh? Tell me.
When we will shift the double bond so that positive charge can come in other carbon where it will be stabilized by the nearby um, ethyl group.
By anyhow, you will take that positive here, or you are saying that by doing resonance. This.
Ma'am, by doing resonance, the positive charge will come at the carbon beside the ethyl group and then ethyl group will migrate.
You want to say like this. Like this.
Yes, ma'am.
Everyone understood what she said?
Yes, ma'am.
Ma'am, like two times you're doing one to metal shift, right?
No, no, no. First, I have done simple resonance of that carbocation. Positive, negative. Positive, negative. Simple resonance. This is nothing but its resonating structure. Correct? Then I have do 1 to methyl shift. After that, the only elimination has taken place. Because right now elimination can't take place because this is quaternary carbon, right? Somehow we have transferred this ethyl group here.
Yes, ma'am.
Good, very good. I think it was Dipali, right?
No, ma'am, it was Bhumika.
Okay, sorry, Bhumika. Actually, I can't see the names now, so this question was clear. Student, it is clear question of your electrophilic aromatic substitution. For this ring, this is your carbonyl, which is your meta directing group. This is your alkyl group, and for this ring, this is nitrogen. So this is plus M, right? And
Yes, ma'am.
alkyl group have plus I, but they don't have any mesomeric effect. So obviously, incoming electrophile will come onto this ring. Now the question arises where it can come at either ortho or para, but no ortho option is given. So obvious clear answer is D. Clear?
Yes, ma'am.
Yes, ma'am.
Very good. This, so I think it is clear to everyone. More the number of electron withdrawing groups, more it will be favorable for incoming nucleophile to. Okay, it will go via which mechanism? Addition, then elimination, or via benzyne mechanism?
Addition, then elimination.
Addition elimination.
Very good, very good. This question clear?
Yes, ma'am.
Yes, ma'am. Clear.
Till here I have made. After that, Grignard attack will form, and on hydrolysis it will be COM. Okay. It will be like this, na, C triple bond N. So first it will form iminium.
This is to form ketone.
Huh. And then it will undergo hydrolysis and will lead to formation of ketone. Clear?
Yes, ma'am.
Very good. This is also clear, I think. Or should I explain?
Yes, ma'am. Please
Anyone in
explain.
the class, if it is not clear, you can please ask. Because
Yes,
I
ma'am.
want to invest more time to that question. Carbene one. Clear, right? Everyone.
No, ma'am, I am not clear with this question.
Not clear? Okay.
No, ma'am.
Okay. Okay. We will do na. So, student, if you will write this as in open form, CO, one thing is clear, right? If you take RCl in presence of AlCl3, it become R positive plus AlCl4 minus, right?
Yes, ma'am.
In similar way, it will become acyl cation, CH, and pH ring is there, phenyl ring.
Yes, ma'am.
Onto one, this ring will attack here. It will become 1, 2, 3. One mistake I have done actually. CO, CH2, C6H5, right?
The Cl will get eliminated out.
No, no, that I have done. But it should form okay, okay, I
Yeah,
got
ma'am.
my mistake. I got my mistake. PH, CO, CH2. Now it will be more clear, I think. CO positive, right? So this bond will go there, and what it will form? Benzene ring will form that six-member ring with positive charge onto this carbon. Till this step clear?
Yes, ma'am.
Now to simple what will happen? Elimination will take place from this side. Okay. Before elimination, what it can undergo? One thing is not correct here. I'm not able to figure out. First, this
Second,
will attack.
form a ketone.
Exactly, because it has attacked onto that carbon, not onto that carbonyl. Exactly.
It
Huh.
comes back as carbon
Now
form.
clear.
Then
Huh. Very good.
gets
Actually, I was seeing I'm making mistakes somewhere. Very good observation. Till this step clear. Now last step, Clemenson reduction. That will
Yes, ma'am.
reduce your
Clear.
carbon into CH2. Actually, very good observation. This carbocation is onto this carbon. Okay. Not it is not oxonium. So it will directly attack there. Clear?
Yes, ma'am.
yes, ma'am.
Very
Clear.
good. Very good. This I will discuss in last when you are having no doubts. Because it is very important. You should know the carbene product of phenol, your pyrrole, your furan, and your this system. This is clear. These two dinone phenol rearrangements are clear to everyone, or should I explain? Should I explain, students? Okay, let me explain this one. Okay, clear, student. Now, if it has to migrate among this carbon or this methyl, which would it migrate? If it migrate this, it will form seven membered ring, right? Which member ring is more stable, six member or seven member?
6 membered.
Exactly. So it will transfer your methyl group. OH, methyl positive. Clear? Now to it will simple undergo elimination in order to get aromaticity back. Clear to everyone how I write this product? Which option is this? Option number C.
Option C.
Because OH and methyl are on same ring, that is on benzene ring, and they are at meta to each other. Clear?
Yes, ma'am.
Now it's turn to go on this problem. This is very important problem. Before it, just tell me, are you clear how to do that Remer-Temin reaction in which we were getting from phenol to salicylaldehyde? Could you recall that? Students, I know I can't add new slide here, but let's delete that thank you and let's study last concept of this semester. Okay. Okay. Student, whenever on arrow it is written CHCl3 plus KOH. Okay. If you write it in open form, CH, sorry for this. If you write it in open form like CH, Cl, 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 base, function of base is abstraction of this proton, okay? So it will become C negative, Cl, Cl, Cl. Now what will happen? One chlorine will leave, and whenever on same carbon we are having both charge, it is equivalent to your carbene. Okay. Now student, carbene can undergo two reactions. Simple addition and another is double bond insertion. Now let's say student, I am having furan. Okay. Your furan, your pyrrole, these rings, these five membered aromatic rings are very electron rich ring. Okay. Carbene is electron deficient. So what it will do students, on one of the double bond, this carbene will attack in this form. How I have found this product? For sake of understanding, I am telling this double bond can be written as positive negative. Your carbene is negative positive. Carbene is carbon having one positive charge and one negative charge, right? So it will form this type of cyclopropane system. Clear? How
Yes, ma'am.
carbene and double bond reacts to form cyclopropane? Charge wise, clear na?
Yes, ma'am.
Now what can happen? It is very interesting. Just you have to focus here. This lone pair will go there. This lone pair will go there. Now there are two possibilities, student. Bond 1 2 can break and bond 1 3 can break. Case 1. If bond 1 3 is breaking, what it will form? Oxonium negative, okay. 1 3 is breaking, right? So it will be Cl, Cl this way. Clear, everyone?
Yes, ma'am.
What will happen? This negative charge will abstract this proton, okay, and that also I will tell you why it will abstract this proton, because as I have told you, this is aromatic ring. It will try all the possible ways to get its aromaticity back. So when negative charge will come here, it will again do resonance and will get your furan back. Okay. And at last, aqueous KOH is still there in your medium. It will be OH. And at last, what will you get? Furforaldehyde. It is also known as furforaldehyde. Furforaldehyde, whatever you call it. I hope this mechanism is clear to everyone. You write it, you will get to know. Clear na, students, boys, girls? Clear?
Yes, ma'am.
Now what say if 1 2 bond breaks? Okay. If 1 2 bond breaks, students, oxonium ion, this Cl, how many member ring will form? 1 2 3 4 5 6 member ring, right? And it will, let's make a 6 member ring, simple. OCH2, Cl, then your 3 4 carbon have double bond, then your 5 6 are having double bond, and in this way. Clear? Now what can do? This can take proton and can eliminate one chlorine. Because here now no negative charge is not on carbon having two chlorines. Okay, only possible way is elimination of HCl, and you will get this product O positive and this. Now tell me student, among A and B, which is stable product? B. Why? Because B is neutral product while A is charged product. Yes or no?
Yes, ma'am.
Everyone is clear, right? Boys, I can't
Yes, ma'am.
listen. I can't. Now you are audible.
Ma'am, the A product is
A product is less stable because it is charged one. Clear?
there is three double bond A product.
Huh. Clear A product is this. Let me again draw na. O double bond. मतलब you can say equivalent of pyridine, but with a positive charge. So among A and this B, B is stable because B is a neutral product. Clear? If you really understood this mechanism, really, could you please tell me the product of pyrrole on reaction with carbene? You can really note down in your copy, student. It will obviously help in your future competitive exam. This is very important question. That furan, furan and thiophene. Thiophene is nothing but sulfur equivalent. Okay, furan and thiophene on CHCl3KOH gives you furfural or thiophene 2 carbaldehyde, this one, and pyrrole gives you what? Can anyone tell me? Pyrrole gives me what? For pyrrole, the major product is
Ma'am,
this
chloropyridine.
3-chloropyridine. Can anyone tell me the
Yes.
reason? Whoever will tell me the reason, he will be topper of my class of today's session. Can anyone tell me why, in case of pyrrole, it is 3-chloropyridine which is more stable, which is major product? Mechanism is same in both the cases. For getting 3-chloropyridine, you have to go by a mechanism of breaking bond 1-2. For 1-3 bond breaking, you will get this furfural 2 carbaldehyde or thiophene 2 carbaldehyde. You take 1 minute time, think over it and tell me. Students, oxygen can't get neutralized by any situation. But do you know this nitrogen is having hydrogen also? This nitrogen will be having hydrogen here in plus form. It can release this H plus and get neutral, right? Because nitrogen can form three bonds. Therefore, pyridine exists in organic chemistry. So now you can say that, yes, pyridine, 3 carbaldehyde, sorry, 3 chloropyridine will be my major product. Yes or no? No one understood this. See, all mechanism is same. Just you replace that oxygen with NH because nitrogen can form three bonds. So in pyrrole, that nitrogen is with hydrogen. At last, where you are getting 3 chloro product, in that product, that nitrogen can remove that H plus to become neutral product. Always remember, neutral products are more stable than charged one. Student, give me any response. Yes, ma'am. No, ma'am. We are not
Yes,
understanding.
ma'am.
Clear, huh? Not clear. Dipali, Bhumika.
Clear, ma'am.
Ma'am, after that OH, I'm not getting the step.
after that OH.
Yes, ma'am. After this step,
This is
what has been
a
done?
carbon having two OH is equivalent to CHO. Lone, it will take a proton from your water, let's say. This oxygen will come back and remove that OH. This is actually hydrate of your aldehyde, na? When
Yes,
you
ma'am.
will remove
Understood.
one molecule of water, it will become aldehyde. In mechanism, do you face any problem?
No, ma'am.
Scan this slide and go back to that problem. This problem. But please, in your notebook, anywhere write that or take screenshot of this. Let me write here. Or thiophene on reaction of CHCl3 KOH, they form CHO. But if pyrrole reacts, it forms, this is minor, this also forms, but it is minor, plus 3-chloropyridine is the major product. Take screenshot or write it in your notebook in a box. It is very important. And if you are clear, then solve this question. Shall I erase all the thing written on this slide?
Yes, ma'am.
Okay. Okay, answer is to see, Just direct me how to start solving. In similar way, student, base will abstract this proton. Okay. Now it is equivalent to your heteroatom. Yes or no? First you are having here oxygen. Then you were having here nitrogen. Now you are having C, carbon with a negative charge on it. Thing will be same. It will form carbene, that will come back and will form that and will break this bond. You will get that six membered ring. Clear? Can you do it by yourself or should I tell? Yes or no? Okay. Let me tell you. No issue. Eraser is not working here. Where is my... What will happen, student? First, this will be your negative charge. Why? Okay. One thing is also why base will first abstract this proton? Because due to this carbon ion, the right side ring becomes aromatic, right? 1, 2, 3, 4, 5, 6. 4n plus 2 rule. Clear? That's why this
Yes.
carbon proton is acidic. Okay. Now next step will be your carbene insertion. Cl, Cl. This bond will come here, this will come here, and this bond will break. And you will get six member ring. 1, 2, 3, 4, 5, 6. I am directly drawing, students. Okay. 3, 4, 5, 6, 1, 2. On carbon number 1, two chlorine atoms are there. On carbon number on carbon number 2, sorry, on carbon 3, 4 double bond is there. 5, 6, 1 double bond is there. And this is clear, students. Now base is there. Base will abstract this proton and remove one chlorine. And at first, your A will be this. Till A, everyone is clear.
Yes,
Yes, ma'am.
clear, ma'am.
Till this point, clear, right? Now again, base will abstract this proton. Why? Because you can write it in this form, correct? This form. Now both rings will be aromatic, right? Again, chlorine will be, sorry, carbene will
Carbon.
insert here. Negative charge will come here. Do this, and at last you will get your C. Now you can draw this product, right?
Yes, ma'am.
So this was from my side. If you have any doubt regarding anything, you can ask me. Thank you for joining the class and bearing me for 8 weeks. All the best, students, for your exams. If you have any doubt, you can ask me.
Thank you,
Ma'am,
ma'am.
I have a
Thank you,
doubt.
ma'am.
Ask.
Ma'am, there was one question maybe in the assignment classes, means the live class, or in the assignment. I'm unable to remember, but I have written that question. Can we just solve that question?
Is there any? You can share it on this screen by any means. I have given all the host controls over there. Wait. Yeah, I have. You can share your screen actually.
Yes, ma'am, I'll try.
Huh.
Ma'am, can I just tell you the structure that how we will be able to form that structure, and then you can
Okay, okay.
continue.
I will try to
Yes, ma'am.
decode what you are saying.
Yes, ma'am.
Just
I'll.
let me find a clear slide. Okay, here I can draw. Yeah, tell me.
Ma'am, the question statement was enolate ion that reacts with 3-butene 2-O to form the structure.
Wait,
So,
wait,
ma'am, the
wait, wait,
structure
wait. 3 butene 2-on.
2-O,
Huh?
2-O
Enolate that reacts with 3 butene 2-on. Huh?
to form a structure, and the structure is, ma'am, there will be cyclohexanone. Two
Cyclo
rings are there.
2
One
ring.
is, huh,
Huh?
one, ma'am, the left one will have on.
This.
Left one ring will have on at the top.
Okay.
Ma'am, no double bond to the left hand side. No double bond.
Okay, okay. Just give me a minute. Erase.
And
Now
this
good.
tertiary, yes, ma'am. In this, where the this joint is there, this tertiary one, there will be a methyl group present here.
Hmm.
Yes, ma'am. Just next to that, ma'am, there will be a presence of double bond.
Here.
Ma'am, no,
Here.
ma'am. Yes, ma'am.
Okay.
No, ma'am, not here. The
Here.
next one. No, ma'am. Other
Here.
one.
Here.
The one that have left. Yes, ma'am. The last one.
Right side one. Okay.
Yes, ma'am. That-
This one,
And
right?
double bond O. Yes,
Okay.
ma'am. And that one for Michael addition kind of right side.
It is example of Robinson annulation, right?
Yes, ma'am. I know.
What problem you are facing in this?
Ma'am, there will be one carbonyl bond also, means double bond O, right hand side.
Here.
Yes, yes, ma'am. Ma'am, the question, like I was solving it, and I was, half I was able to solve. Ma'am, you also told that when such things are possible, there will we can also break this down and
We can draw
like
its
although
retrosynthesis.
yes, ma'am. Can you just you did not do the retrosynthesis in that
Okay.
question, so I
Okay.
am asking for that.
Let me try on whatever you have given me information on basis of that. Let me draw it OH because at last step of Robinson annulation is this one.
Yes, ma'am.
है ना? How this can be found? Let's break it from here or from where we can break. Okay, if
Ma'am, and all the options that we see has the first group, first left hand side will be like cyclohexanone will be there, and at the there will be one side there will be or methyl group, and then one side there will be negative charge. Then like that options are there.
first of all they are saying 3 but 2 in 1. This is nothing but I think this.
Yes, ma'am.
1, 2, 3. Clear now? 1, 2, 3, 4. 3 butene 2 on. This is your methyl vinyl ketone. Okay. Now what can happen is they are taking diketone. I'm just guessing it because you have not given me complete information. Wait. Actually, you have given me, but
Options have not. Yes, ma'am.
Mhm.
And ma'am, this is the only correct option, the one that you have drawn with the negative charge.
Okay. Let me see. So one thing is clear, it can attack from here, O negative methyl. Clear? Now I have told you that you have to do first protonation, double bond O, COMe. Now 1, 2, 3, 4, 5, 6. 6 member ring will form. Double bond O, OH, 6 member ring. Double bond O. Yeah, done. It's done. Here only Me will be there. So you can have. So you have
Yes.
to take enolate of this and you can take methyl vinyl ketone. You will get that product.
Ma'am, the question was like here in options, there are options and how to do this Robinson annihilation, first Michael addition, then we are doing intramolecular, everything I have understood. But for time, because it is like MCQ questions and we'll have to devote our time for that, just by seeing the options like in Aldol we used to revert, we used to go in the
Actually,
reverse.
you
This there
you
is no
want to
trick for
know the
that.
strategy which I have told you in Aldol
Yes,
here, है ना?
it's
But
because there's
for
key
this, so you have to solve because
for each
questionnaire
option.
can ask you in any form. Here we have to do solve step by step. But how I have solved is you have told me that methyl vinyl ketone is there. Okay.
Yes,
So
ma'am.
once it will form ketone, now I also know by looking at the product, methyl is at junction. So that enolate should have methyl. So I have drawn this. Ki that active methylene carbon will have one methyl because this is there. Then by drawing a product I know first this oxygen lone pair will come back, will form ketone, and after that again base will take proton from this carbon, and this carbon is going to attack here. Once you remember the sequence na, first Michael
Yes, ma'am.
addition, then oxygen lone pair quenching with H plus, forming ketone. Now again base will abstract proton and aldol reaction will take, intramolecular aldol reaction will take
Intra.
place. Once you know this sequence, you can easily get to this product.
Yes, ma'am.
I
Okay,
hope it
ma'am.
is clear to others also. Yes, other doubts?
Excuse me, ma'am.
Yes, Mansi.
Yes. Ma'am, in some weeks, like week 7 and 8, there are so many reactions and rearrangement reactions.
Huh.
So sometimes while we are revising, all of them feels very similar and gets confusing. So, ma'am, if in the exam, like if we see a particular reaction and we are not able to immediately identify which one it is, so what should be our like first approach to that reaction?
See, as far as I know, whatever last week rearrangement reactions are there, they involve carbocation in that. So for that basic understanding you should have is, first you have to make carbocation, then you have to maximum stabilize it, mesomeric, aromatic, resonance, hyperconjugation, inductive. Once you have done stabilization, you just have to do rearrangement. 1 to methyl shift or ring expansion. Only name is different. For example, let me revise you here only. What is your dinone phenol rearrangement? In your dinone, your oxygen will be first activated in presence of acid, then 1 to methyl shift will take place, and after that simple aromatization will be done, as I have discussed in today's class. That is your dinone phenol rearrangement. Pinacol rearrangement is, you are having diol, one of the OH get activated, carbocation will form there, then rearrangement will take place so that that carbocation will be stabilized by mesomeric effect of nearby carbon having hydroxy group, and at last ketone will form. This is your pinacol. Semi-pinacol are, instead of OH, first OH that is becoming carbocation, they can give you another leaving groups. For example, N2. For example, they can give you chlorine, fluorine, so that carbocation forms and you have to make them stable by nearby hydroxy group. So these variants can come.
Yes,
Okay.
ma'am.
And name reactions are all around your carbonyl groups. Aldol, Cannizzaro, your Robinson annulation, Cannizzaro reaction हो गया. Benzyl benzylic acid rearrangement, or
Isocyanate one,
हाँ,
that
that are
Curtius.
nitrine based. Hoffman, Schmidt, Lawson, Curtius reactions. Actually, Mansi, you can go through my slides, or not slides, my videos which I have discussed. In that, I have uh, explained in detail all the
All
reactions
the
mechanism and their problems.
Yes, ma'am, I've seen.
Okay. I hope it will help.
Okay,
Let,
ma'am. Thank you, ma'am.
let me